and welcome to another episode of Elktech. So today we are in our 5th episode here in the series of the insides of the computer and how it works. Today we're going to be talking about memory in multiple different facets. So we have two major different types of memory. We have ROM, which is read-only memory, and we have RAM, which is random access memory. ROM is found on the motherboard and other circuit boards. It contains instructions that can be accessed by the CPU. These instructions contain basic operation type instructions, such as how to boot up the computer or how to load the operating system, so on and so forth. ROM is very interesting, as ROM is sometimes called firmware. However, that's not actually completely accurate, as firmware is actually the software that's stored inside of the ROM chip. So the other thing that's important to understand about ROM is that it is non-volatile. So when we talk about volatile and non-volatile, non-volatile means that when the power is shut off to the machine, it does not lose the information in which is stored on it. Now, RAM, or random access memory, is volatile. So as soon as you turn off the computer, anything that's in the RAM chip is gone. It basically gets wiped out. And that's one of the reasons why there is such a big dispute about whether or not you should leave your computer on or whether or not you should turn it off at the end of the day. There are many great arguments on both sides, but one of the best reasons to at least shut down once every now and again is so that you can actually fully clear out your RAM, because that's the way that you're going to completely clear it out, is by shutting off the power. So with RAM is random access memory. It's a temporary working storage for the data and programs that are being accessed by the CPU. So you can think of it like a workbench, and you're placing all your materials and everything that you need on the workbench in order for you to be able to work with it. It's the same basic concept. The RAM is where you're going to store all that data so the CPU can access it and process it as needed. Again, RAM is volatile, so you shut off the computer and boom, it loses its data. Now, there are different types of RAM. So on the screen here you can see that there's DRAM, there's SRAM, there's SDRAM, DDR, DDR2, DDR3, and DDR4. So your DDR RAM is your double data rate SDRAM. Okay, so your DDR there is SDRAM, which is the newest type of RAM, which is what we use currently. Won't really go into the DRAM or the SRAM because they're basically obsolete. You shouldn't find those almost anywhere. In fact, the only real relevant memory as of now is DDR2, DDR3, and DDR4, and even then DDR2 really isn't all that relevant anymore. So what's one thing that's really interesting and important to note is that when you look at the chips in front of you, your DDR RAM, your DDR2 RAM, and your DDR3 RAM all have a break in different spots. Alright, this is one way that you can easily tell them apart by just looking at them. The DDR and the DDR2 are very close together, but you really shouldn't have too much of an issue because you shouldn't really be finding DDR RAM. And then you have your SODIMMs. Now, these SODIMMs are used more in your laptop computers, but it's the same basic concept where you have that break in different places. We're going to go a little bit further in detail with that a little bit later. So your DDR2 RAM is twice the speed of DDR RAM. It also decreased the noise and the crosstalk between signals, between signal wires. So each one basically got better, obviously, as they came out. That's the purpose of upgrading, right? Your DDR3 doubled the clock rate of DDR2, expanding the bandwidth, but it also consumes less power and generates less heat, which is really important. So DDR3 was kind of a huge advancement, and we went for quite a while with DDR3 before DDR4, which came out somewhat recently, within the last 2 years. And DDR4 actually quadruples the maximum storage of DDR3 and requires much less power due to the lower voltage that it uses. DDR4 also has some advanced error correction features which are really nice. your memory modules, you have a couple of different types here. So with your memory modules, you have your SIMMs, your DIMMs, and your SODIMMs. So this can be really important here because your SIM is your single input memory module. Your DIMM is your dual input memory module. Basically all that really means is that the single input memory module means that you have memory on one side, dual means that you have memory on both sides of the chip. So really looking at your RAM here, your SIMMs have 30 or 72 pins, and that's these pins that are right here, okay? So then you have your 30 and your 72. Then you get into your DIMMs, which can be 168 or 240 pins, okay? So your DIMMs are going to be your DDRs, your DDR, DDR2, DDR3, and DDR4. They have memory on both sides. Your SODIMMs can be anywhere from 72 to 204, okay? So basically you have your SODIMMs and your DIMMs, which are going to work basically the same but in different sizes. You're just sizing down the pins here in order to make them fit into a laptop. All right, so hopefully that makes sense. RAM is really something that you need to be aware of because it's something that you really need to make sure that you're choosing the right RAM for your system, okay? So adding RAM to your computer will enhance the system performance. Without the RAM, data would need to be stored on the hard drive, which is much slower. So increasing the RAM allows for more workspace essentially for the CPU to process different applications and files, so on and so forth. And a lot of us like to open a whole lot of things. So your memory really helps with that and being able to allow the processor to better process that information. One other thing to look at with RAM is your transfer rates. So when you go to actually purchase RAM, it's really important to look at this transfer rate. So you get your motherboard and you're going to have to look at that motherboard and you're going to have to figure out which processor you want based on the socket that's on the motherboard. On that motherboard, it'll also tell you which rates it supports as far as the RAM, whether or not it be the 1066, the 1333, 1600, 1866, and this actually gets even higher. As we get into our DDR4 especially, we can get into the 2133 all the way up to 3200. And again, these are very important because as you can see the gigabytes per second here. So as you start to move up, you can transfer more data, and again, as long as you have that front side bus that can handle the transfer rates with a processor that has a high cycles per second, then you can add higher gigabytes per second in your RAM and you can really optimize the speed of your computer. And just remember too that when you're building a computer, you can't just buy a top-end graphics card and hope that that's going to make up for poor system components in the other ones. You really have to make sure the whole of the computer is up to speed. So like I said, make sure to pay attention to these, because if you get a set of DIMMs that are running at say 1866, but your motherboard doesn't support that speed, then you're looking at a potential issue there where either the RAM won't work or it may slow itself down because it's not working properly. So make sure that you match those numbers from the motherboard and the RAM, alright? Next, we're going to talk about CPU memory. Now, obviously, we already talked about the CPU in a past video, but what we're going to do is we're going to talk really quickly about the actual CPU memory. So the CPU actually has memory that is built into the processor. And these are called your L1, your L2, and your L3 cache. Now, it used to be that your L1 was built into the processor, the L2 used to be built into the motherboard, and the L3 used to only be for high-end workstations or server CPUs. However, that's actually not the case anymore. Now, your L1 and your L2 cache and your L3 are all going to be integrated into the CPU, and you're actually going to find that L3 cache in most all of your, especially your Intel-based processors. So if you go and get an Intel Core i3, i5 processor, they're going to probably have an L3 cache built in. And this is memory that basically the CPU can use before it needs to actually use your system memory. This memory is much, much faster than the memory on board your computer. But it's also very limited. It may only be like 8 megabytes. So it's not going to be at the size of your actual memory. So it's still important that you have a lot of that onboard memory at a good speed. All right. So hopefully this tutorial helps you as far as memory. Make sure that you subscribe to my YouTube channel so you can get all the latest videos as they come out. Also, make sure that you check out my website if you're not there already. It's in the comments section below. I'll have lots more videos there, not just in this series, but also in other series, as well as all kinds of tips, tricks, and tutorial videos, how-tos, so on and so forth. So check those out, and thanks for watching.